Hello. Uh, we will discuss the same question, but we will use sequential criteria to solve this question. So, what is the sequential criteria? Let us first write the function again. Fx is equal to 1 if x belongs to 0 to 1, union 1 to 2, and 0 if x belongs to if x is equal to 1. So, what is the sequential criteria for a function to be continuous? So, a function f is continuous at x is equal to a if and only if for every sequence if and only for every sequence xn that converges to a f xn converges to fa. So I want to show fx is discontinuous at x is equal to 1. So I will use contradiction. Suppose that f is continuous at x is equal to 1. So using this sequential criteria, f is continuous at x is equal to 1, how in this case a is equal to 1, then for every, this is true if and only if for every sequence xn which which converges to a, fxn converges to fa. So let's take a sequence xn is equal to 1 plus 1 by n. Then my claim is xn converges to 1. So what is the definition of convergence? Convergence of a sequence. A sequence xn is said to converge. Is said to converge to L if for every epsilon greater than 0, xn minus L is less than epsilon. If for every epsilon greater than there exists k belongs to natural number such that mod of xn minus L is less than epsilon for all n greater than equal to k. Now my claim is xn converges to 1. So let's see how we can prove this. What is, let's write it down. Xn is 1 plus 1 by n minus L. L I am taking to be 1 is less than epsilon for all n greater than k. 1 by n is less than epsilon for all n greater than equal to k. So let's we want to show this, right? Let's I mean let n0 be such that not n0, let's say let k be such that epsilon is greater than 1 by k. We can find such a k belongs to natural number exists because k because the set of natural numbers n is unbounded. Okay, so now if we take any n for all n greater than equal to k, 1 by n is less than equal to 1 by k, and using this is less than epsilon. So 1 by n is less than epsilon. Now you can take mod because n is natural number, so positive. So this is what we wanted. For all n greater than equal to k, this thing holds true, which is equal to this thing is true. So we have shown that xn, which we defined as 1 plus 1 by n, converges to 1. That is, so since fa, now use this condition, we have assumed that f is continuous at x is equal to 1. So we will use this sequential criteria. F is continuous at x is equal to 1, a is 1. Then for every sequence xn which converges to 1, we have in our case we are using 1 plus 1 by n as our sequence. It converges to 1. We have shown that this xn is converging to 1. Just now we showed that. Then fxn should converge to fa. Right? What is fa? Fa is equal to, in our case, f of 1. F of 1 is 0. So f using sequential criteria with xn is equal to 1 plus 1 by n. F of xn should converge to f of 1, which is equal to 0. So fxn converges to 0. Now let's see what is fxn. Fxn is equal to f 1 plus 1 by n. Right? Since n is greater than n is natural number, then n is equal to n is greater than 0. So 1 by n is greater than 0. 1 plus 1 by n is greater than 1. So what is the value of f at a value greater than 1? In 1 to 2, f value is 1. F of 1 plus 1 by n is equal to this value is equal to, what is it, 1. Yes, this value is 1. So uh, now for all, this is for all this fxn. Xn is 1 plus 1 by n. This is equal to 1 for all n, because for any n is greater than 0, so this calculation will hold, and fxn is equal to 1 for all n. So the fxn sequence is fx1, fx2, fx3, so on, and it is all 1. This is a constant sequence, so fxn converges to 1. Now this is our equation 2 and this is our equation 1. Fxn, now we will use the thing that if a sequence, let's say yn converges to L and yn converges to L dash, then L is equal to L dash. So in this case fxn is our sequence. It converges to 0 and it converges to 1 by 1 and 2. So by 1 and 2, 0 is equal to 1. Okay, and we also know that 0 is not equal to 1. This is a contradiction. So our assumption that f is discontinuous, f is continuous at x is equal to 1 is wrong. F is discontinuous at x is equal to 1. One small mistake is that uh, if we put n is equal to 1 here, and this will be f1 plus 1 by 1. F of 1 plus 1 by is f of 2, and f of 2 is not in the domain of where is this function. Yeah, 2 is not included. So actually you can modify this sequence. Take xn to be xn to be 1 plus 1 by 2n. Some same logic will work, but now we won't get the error. I mean this problem. F of 2 is undefined, right? So this is the mistake. Instead of instead of taking xn is equal to 1 plus 1 by n, you take xn is equal to 1 plus 1 by 2n. The same thing will work, that xn goes to 1. You can show it, right? And then this argument will work, and we'll got a contradiction, and we can prove that fx is discontinuous at x is equal to 1.